Hello, welcome. I am Scott Nichols. I work on Knative day-to-day at Google. This is the Botless talk on building a serverless chatbot framework. We are going to be building the Botless framework together right here. We will optimize for cost and flexibility of extensions. The customer will be my team or my company. While building Botless, think of opportunities for you to provide your own framework. Encapsulation and reusability are powerful techniques. First, some background. This started because I wrote some scripts to do some useful checks. My team started pinging me, asking me about the results of these scripts. Here, Grant is asking me how long the database has been up. I get interrupted, I run the script, and I tell him the results. So my team and I started writing more useful scripts, and we connected them to our chat server, and they did little tasks for us. At first, these were little one-off programs that ran on our desktops, and this was great because no more interruptions. Now each script could respond to its own command, and it was useful. Our partner team saw how useful our chat scripts were and started writing their own. But their scripts used the talk server, not the chat server. The two teams noticed each other's scripts and started forking some of them. Because each script talked to a different chat server, each had to be modified to work. This started getting out of hand. If Bob went home for the night, we stopped being able to check the health metrics or deploy the latest software to QA. It turns out running apps on desktops is not the most reliable. So we did a little work, and we wrapped each script in a container and pushed those into Kubernetes. And we gained a lot of reliability, but we also realized there was a lot of redundancy. Another issue was that each script was connecting to the chat servers directly, so that code had to be duplicated everywhere. We got the great idea to add a small adapter between the chat server and the scripts, so we could consolidate the chat communication logic. That forced us to standardize the command communication between the adapters and the scripts. We started writing a lot of scripts. This was not great because people started realizing that each new command took pods in the cluster. Each new command meant the chatbot started costing us more money and more infrastructure. We knew we could do better. Let's pick apart the aspects that became important to the team. We realized early that using Kubernetes and containers allowed the developers on my team to write in whatever language they wanted, as long as we all agreed on the inputs and the outputs of the container. So a side note, formalizing a protocol for yourself will increase the reliability of your application. Standardizing on the shape of the input and the output frees you to choose the best language for the job. We also realized the team is only interacting with the bots for a small portion of the day. And even when we are interacting with only one chat script at a time. Further, the number of commands that we created increased the overall cost of the service. We wanted to pay for just when the bot was being useful, not idle. If the chatbot supported a more serverless architecture, we could stop worrying about the idle cost and reserving of resources. When we interact with the bot, the one command that should be active, and the rest should be, well, serverless. not running. Serverless means no servers are in use when the application is not actively doing something useful. It scales to 0. Serverless means elastic. It can scale up very quickly to handle demand. Serverless is event-driven. It's reacting to something. And we only want to pay for the amount of time our app is doing something useful. Okay, so our main requirements ended up being, 1, we use containers so that everyone can pick the code language that they want to implement. And 2, use a serverless technique to reduce the overhead for having so many chatbot commands and not paying for the idle time. Containers means Kubernetes. And Kubernetes and serverless is slightly more tricky, but we have a few options. There's FN, OpenFaaS, and Knative that come to mind. I will pick Knative. Knative is setting out to be the building blocks for serverless workloads on Kubernetes. Knative provides primitives to build on, serving for functions, eventing for delivery and routing, and build for in-cluster creation, in-cluster container creation. Come check us out on GitHub. Knative is a new project from Google in collaboration with Pivotal, SAP, Red Hat, IBM, and many others. Knative builds the serverless primitives that Kubernetes lacks. We are enabling an ecosystem of serverless products to be built with portability in mind. Back to Botless. At the base of our stack, we have Kubernetes for rock-solid container orchestration. Extending K8s, we have Knative, providing those missing serverless components. Building on those is my Botless framework. And at the top, there's room for features and extensions. My team brings along their bot commands and the chat server adapters. And the general picture of how this looks is we can have our existing chat server communicating to a receive adapter. The receive adapter bridges the chat protocol into a common protocol for the framework to understand. We will need to parse the incoming messages to understand if they are commands or not, and then a router to link a particular command to a serverless function that handles it. Here again, the chat server speaks whatever protocol it happens to be implemented in. We cannot change that. But we can convert it into something standard, into a standard format. Here we will take raw chat events, and the receive adapter will output a new emerging standard, CloudEvents, with an event type, say, dev.botless.chat. CloudEvents is a specification for describing eventing data in a common way. For example, here's a Cloud Event envelope as taken from their specification. The point of this is that the outer wrapper is easy to understand and route between event producers and event consumers, possibly passing through middleware. We can combine the concepts of the external chat server and our internal receive adapter into a new object called a chat source. The source is a general Knative eventing concept for a component that pushes events into the cluster. We can represent that source as a custom resource. Here's the YAML for our chat source. Each logical component in the diagram is represented inside the source spec. The concept of a source is abstract. Its role is that it pushes events into a sink as we are free, and we are free to define anything else that is interesting for our exact use case for that source. We encapsulate the logic of the chat server communication in the chat source. In this case, it converts simple chat messages into a cloud event. This is what the parser will receive to do its work. With the chat source, here is what we end up with. We have a chat source pushing events into the parser. The parser produces a bot command and sends them to the router. The router delivers the command message to the function that implements that particular command. Knative is leveraged in these places. It connects the components. It enables the commands. Let's talk about how. Knative eventing is used to deliver events to endpoints. It does this with an abstraction called channels and subscriptions. Channels represent a delivery method for events. In practice, this means an eventing queue, something that allows for durability of the event delivery of events. Knative has abstracted this away to be able to use things like queues without being tightly bound to a particular queue implementation. A subscription describes event delivery. A subscription tells the upstream channel to first call a subscriber function and then continue the reply to the next channel. Channels that have more than one subscription allow for fan-out, or multiple event deliveries. Also shown are the current ways we support connecting callable functions and channels. Those callables are interesting because you can choose to use them like a filter. Here's a pass-through filter. Or it can mutate the event. Or it could filter the event out entirely. Let's expand our current Botless framework with the eventing components and see how it would look like in practice. We have these three components connected, the source to the parser to the router. In serverless applications, it's best to never call a function from another function. Knative eventing gives us primitives to implement the best practice, channels and subscriptions, and it would look something like this. Events flow from the source into a channel. The channel passes the event to the subscribers of the channel. For Botless, the subscriber of the new message channel is the parser. The parser's job is to examine the new chat message and see if it fits the format of a bot command. Bot commands in Botless are all chat messages with a / and then the command. If the parser sees a /, it creates a new event, a bot command, and returns this event. Otherwise, it returns nothing in response to the incoming message, and nothing is sent to the command channel. If the parser produces a bot command, the message is passed to the bot command channel. The bot command channel sends its events to the router. The job of the router is to inspect the event metadata, and route it based on the command name. The router looks at the existing channels and finds the one that matches the label produced from the command name. The router passes the bot command to the correct channel. The command channel invokes the function and forwards the response to the response channel. If no channel is found, Botless has a default channel to send an error response. A command is not very useful without a way to reply back to the original requester. We need to add a component for transmitting the responses back to the chat server, the transmit adapter. We also need a way to remember which user issued the original command. We can use an extension on CloudEvents to correlate events from which the original message came. Here we can see the channels explicitly called out in the architecture with implied subscriptions. Now, the chat source and the transmit adapter. Now we have the chat source and the transmit adapter, and we will come back to that. We have looked at most of the system, but not actually how the chatbot does its work. What about those commands? I said they are serverless. Here we can leverage Knative again. We can leverage Knative for serverless functionality. Knative serving provides the abstraction for running a container as a serverless function, a Knative service. Serving also provides concepts of revisions that can enable deploys for your functions and tools to help route traffic to them. Check out Knative GitHub repo for more information on that. Botless will leverage the service object to enable simple serverless functionality. Botless can provide encapsulations for objects for our team to build on. Let's look for a place to reduce complexity for our team. We have to write some code to bridge the messages from the chat server. And then, as the command responds, the two components, and then the response object. Those two components are linked together because they have very similar code that implements them. In fact, they share authentication required to communicate to the chat server. Perhaps they could share a persistent connection as well. If the component has both a receive adapter and a transmit adapter, it's called a gateway. To make it simple for us to manage and deploy, we made a new CRD for Botless to wrap the gateway as a concept. This deploys inside of Kubernetes as a logical unit. We define a new custom resource definition. This plus a controller that runs inside of our cluster that manages the control plane aspect gives us a gateway. And then we can create a chat gateway resource like this. We provide the remote chat server and the two channels that the gateway communicates with to the rest of Botless. And when the chat gateway is created, our custom controller makes sure that the source and the transmit adapter are created for us. We focus on making the best chat gateway we can. We do this to be able to focus on the app at large without attempting to reconcile and orchestrate the entire application at once. And here, with the gateway, we have reduced the complexity of our application by extending Kubernetes. How about expanding what Botless can do? We could make it easy to deploy new commands inside of services, but because I trust my team, I could make a command that automates that feature from within the chatbot framework itself. So, a learning command. And here's what that would look like installed inside the cluster. The code has been converted into a container, and the channel links it to the router. But how can we convert source code into a container? Knative serving and Knative build help with this problem too. Knative provides the fundamentals for a build pipeline that runs inside of Kubernetes. With a little bit of planning, Botless could have a set of build pipelines that take in get URLs and results in a container image. Great. Now we can invoke commands, get responses, install new commands, but if we find out that the sales team wants to use the bot as well, we can have them build upon what we have. We could build them a talk server. We could build them a talk gateway. And with a couple of correlation IDs, the messages filter out just fine. And because we understand how to produce a cloud event for chat event types, we can wire it up to the existing channels without worrying. So there it is. We made a serverless chatbot framework. We are leveraging serverless tech empowered by Knative to get moving quickly. We have extended Kubernetes to encapsulate the features of our application. I want you to leave here with these thoughts. Think of Kubernetes as a way to extend your application development. You can build controllers that do very specific things very well. And if you are careful about composability, you can build very complex applications that are also maintainable. Knative is an example of the power of extending Kubernetes to build your own framework. And Botless is an example of building a highly customized framework on top of that. Thank you.